Basic of electronics for beginners. If you want to learn robotics, then first you have to be understood about basic of components and how we have to use it and how we have to measure it. And then after that we will study about the simulation of these components. If we will build any kind of circuit, we have to simulate it, then we have to build a prototype, and after that we can build a final product or robot, whatever we want to make. For that, first we have to understand what is Ohm's law and what is input output and what is analog and digital. So first we will understand about basic components. We will start from the push button. Push button is digital input and output, not output, only input. Trim potentiometer, that is only used for analog input purpose. Photoresistor, which is used for measuring day and night effect, daylight. Analog input. Relay module for actuator, working as an actuator. Temperature sensor for analog input. Flex sensor, analog input. Soft trim pot, also for analog input. RGB LED. What these components work? These components work for different applications that's shown on the right side in notes. Polarized need resistor are called a trim pot. Resistance varies with light. All the application is shown over here, and function also shown over here. Then after that we will discuss about jumper wire. And jumper wire is used for connecting two points to terminals in the circuit. We always use on the breadboard and for connecting different sensors on microcontrollers and board. And resistance is also shown over here. We will discuss in detail that how resistance work and how we can change values. Then LEDs, you can see LED over here. There are three colors of LED. Which one is positive, which one is negative terminal of LED you can identify. The bigger leg is positive and smaller leg is negative. Then we will discuss about potentiometer. Potentiometer have three legs. It's used for dividing voltage or controlling output voltage. We always use in controlling speed of fan, controlling speed of cooler and different appliance, or increasing and decreasing volume of electronics appliance. Diode is also used for DC application. Now photoresistor is shown like this. It's bipolar. Then temperature sensor is used for measuring temperature in environment. And then DC motor has two terminals, positive and negative. If we are using reverse terminals, reverse polarity, then direction of motor get changed. In similar way, piezo element is also known as piezo buzzer. If we have to create any kind of sound, then we can use piezo buzzer. Then transistor can be used as a switch or as a amplifier, but in robotics major application we will use transistor as a switch. There are two type of transistor, N type and P type. We will not discuss in detail, but we have to be understood that how it works. Push button is also shown over here. The cross terminal is used in push button for connecting any circuit. Flex sensor for increasing and decreasing resistance. If we are using clubs and using sensor for measuring flex, for that we can use flex sensor. Soft potentiometer also work as a similar way. Then servo motor for controlling position of any particular device, appliance, we can use servo motor. Servo motor rotate only 360 degree or 180 degree. It cannot continuously revolve. It will only complete one revolution. These are the relays, integrated circuit, LCD, and then breadboard. In breadboard, how we have to do connection, that is very important. First we have to understand that how breadboard work. Breadboard is used for prototyping, and how their connection is, that is shown over here, that how the inner part of the breadboard is connected. You can see over here the two rows connected over here internally, mean if we are connecting something over here and second wire we are connecting over here, mean both are internally get connected. That's the application of breadboard. Mean we no need to twist any wire, we can use on the breadboard without twisting, so that we can reuse it. Similar way in column are connected, half portion from over here to over here are connected. There are approximate 5 terminals, 5 points, and similar way in horizontal direction they are not connected, only vertical direction they are connected. You can see over here clearly, and this is also very clear picture that how these connections are connected. This yellow sign indicate that these points are connected, and in here over here in left side you can see how rows are connected. Each rows of 5 holes are connected. Vertical columns called power bus are connected vertical. Now we have to understand what is Ohm's law from the basic, and then we have to understand voltage, current, resistance, and how to use multimeter. So we will start from the basic Ohm's law. Ohm's law simply shows V is equal to IR, voltage is directly proportional to current. So how practically it works, that we have to understand. V is equal to IR, the practical application. You can understand from the basic. V is voltage. Voltage, how it works. Voltage is just a potential difference. We have to understand it very clearly. When we put any electrical circuit and we feel any kind of shock, it means we never used to say that it's voltage shock. It's always always used to say that it's current shock. Mean voltage is just a potential difference, and current is used to flow in a particular circuit. It's charge, rate of charge flow in a circuit. And resistance oppose the flow of charge. That is very important part. We have to understand from simple current flow analogy that how it works. Now in simple way, high current you can see over here in water tap. A water tap is open fully, mean high current is flowing. And if your water tank is on second floor or third floor, if more height mean more flow of current over here, mean more pressure over here. In second, you can see you have closed your tap, and now you can see very less current is flowing. Current is the synonym of water. Now you can understand very clearly that what is voltage. Voltage is potential difference. Higher the height of your water tank, mean more current will flow over there. Lower the height, mean less current is flowing in the same diameter of the pipe. In similar way, you can understand that how a continuity can be checked in the multimeter. Multimeter is used for multiple applications. As its name shows that multimeter, multiple application can be used and multiple things can be measured on the multimeter. So first we have to understand that how a circuit is completed or closed, or any breakdown in the circuit that can be done with multimeter. Like if we have put it multimeter over here, then we can see we have to put this knob over here, then we can touch both the knob of multimeter, then a beep sound is produced by multimeter. That shows that connectivity. If we have to check any circuit that it's complete or not, is there any breakage in the wire, that also we can check with the help of multimeter. So that you can do simply. Now we have to measure electricity, we have to measure voltage, then we have to measure current, then we have to measure resistance. These are the 3 parameters of Ohm's law. We have to measure it, we have to verify it, and then we have to go ahead. So first of all, we have created a circuit, simple circuit. Here is voltage source, here is LEDs connected, this one is resistance, 330 ohms resistor, and now a circuit is complete. You can see over here that current is flowing in the circuit with closed loop. So we have to measure voltage. Voltage is always measured in a parallel mode, not in a series, in parallel mode. So we are putting one knob is over here, second knob is over here, means voltage across this LED, not complete circuit. Means if we are measuring voltage over here and over here, mean that voltage will be of battery voltage. Here this voltage is across LED and this voltage is across resistance. Each voltage you can measure. LED, across the LED you will find approx 2 volt that is needed for the LED. If voltage is higher than 2 volt, mean LED is in danger mode. So we will simulate in next few slides, then you can understand very well that how voltage and current can be measured. You can see in multimeter there are different knobs in voltage. You can measure it like 200, 600 volt. These are DC voltage. You can these are AC voltage terminals and these are DC voltage. You can measure from 200 millivolt to 600 DC voltage over here. Now if we have to measure current, we have to put our multimeter in the series, then only we can measure current. Current is just flow rate. Flow rate can be measured by using a series circuit. Mean current should be flow through the multimeter, then you can measure it. Mean now circuit is open, current is flowing through the multimeter. For that you have to put your knob or multimeter in the current section, that how much current it is. That can be measured with the help of multimeter. Resistance is also similar way. You can measure with your multimeter by putting both the knob of multimeter in the resistance both the end, and then you have to put your multimeter knob over resistance box, and you have to choose which one resistor or under which limit you have to measure it. Now it's very important. Till now you just did theoretical part. You will not understand a small thing about it, that how voltage work, how resistance work, and how a complete circuit work, and how we can measure voltage, current and resistance. But now all the things we can simulate in a very simple and easy way in a small online software tool. So no need to install anything, no need to pay anything. You can do free of cost your simulation part. So what we have to do for that, we have to open this website Tinker CAD. You have to create your account over there, and then you have to move ahead over there, that how you have to simulate. I will show you step by step that how you can do simulation of the circuit. So first what you have to do, you have to open Tinker CAD on your web browser, and then you have to create your account over here. After creating your account, you have to do sign up. Free of cost you can do sign up with your Gmail ID or any other mail ID. And after doing sign up, what you have to do, I have just did sign up. You have to open circuit part, and in circuit, below circuit part there is lesson. You can understand each and everything by step lesson plan. So first we are just opening Ohm's Law. So we have to tinker this. These are the tutorial part that you can do on your Tinker CAD. So we have to go to first step. First step is that this one is Ohm's Law circuit. It's shown over here. Similar way this circuit is created over here. You have to understand it, how it works. What is Ohm's Law, step by step. You have to follow all the steps. Then you will easily understand that which one is positive terminal, which one is negative, and how we have to connect LED. And as a simple way, I'm just showing you how you have to connect. I'm just disconnecting each and everything. If I'm just deleting each and everything, how you have to brought all the things together over here, and then you have to simulate. So first I'm just taking LED. You have to drag and drop over here component from just picking component from over here and just putting over here. Just I'm dragging and dropping over here. So we have to connect resistance over here. Just I did it. This one is cathode. Cathode is positive and anode is negative. Sorry, I just told reverse. Cathode is negative and anode is positive. So we need battery. All the in basic component you will find battery. Yeah, this one is battery. You have to brought it over here. This one is part is negative. This one part is positive. So negative part should be connected with this part. So I'm just connecting it, just putting it at lower side. Now we have to connect positive with this. So I just directly connected without any button. So what we have to do now, each and everything is written over here in detail, that how it works. V is equal to IR, and this button is also put it over here. So next what we have to do, we have to simple circuit of LED. They shown over here like this. You can create like this, or in other way also you can make it by rotating it, like I'm just showing you. Make it, just take it, any way you can create it. Yeah, did it. Now you have to simulate it. Start simulation. Simulation option is over here. This one is for coding purpose. When you will do in advance, then you have to do coding, that I will let you know later on in next tutorials. These are for export application. We have to import and export, that also we can do over here in export section. You can use for any application, like if you have to make a PCB or something like that, that you can do. In share option you can take screenshot of it and you can share with your friend also. So what we have to do, we have to simulate now. So just start simulation. You can see LED is glowing. So stop simulation, it's not working. Now what you have to do, now you can change value of this resistor. According to Ohm's law, how much value is needed, that I will let you know. V is equal to IR. V is supply voltage, and we have to subtract LED required voltage. Supply voltage is 9 volt. LED general standard required voltage is 2 volt. So we have to put 7 minus 2, that is equal to 5, is equal to I and R. I is current required for LED, that is 20 milliampere, 20 milliampere, means that you have to put over here. After that R, you have to divide 5 divided by 20 milliampere. So how much it would be? It would be approximate 330 ohm or 340 ohm. So that you can do calculation according to your convenient. So I'm just putting over here, just checking that it is correct or not. 330, it's not a kilo ohm, we have to make it ohm. Yeah, now we can start simulation. Yeah, it is in danger zone. 20.9 milliampere current is flowing and required is 20 milliampere. Everything is written over here, mean you know your component will not get damaged when you are simulating over here. Now we have to increase it. I'm just doing it to 430, then after that I will check it. Yeah, now it's working fine. There is no any danger sign. So this is what you can do. You can just simulate, you can change value, and you can use multiple things via online. Just your internet speed should be good, so that you can do simulation in a proper way. Sometimes there are a lot of queries used to come that, yeah, my circuit is not properly working, I'm not able to drag and drop, software get hang out. It's nothing like that. It's so simple software. You can see over here, whatever I want to import, I can do very fast way. You can see over here. So I'm just not going to take these things. So you can delete all the things also, but I'm not going to delete now. Okay, so this is one of the basic circuit. Now after that you have to go to your Tinker CAD, and again you have to open second tutorial. In tutorial you will get detailed part, that how you have to simulate your circuit. So in today tutorial we will do about basic circuit. In next tutorial we will do about Arduino simulation and how to interface Arduino in real time. That we will do in later on. So in lessons we have to move ahead, that which one lesson we have to do. Now we have to come up with series parallel circuit. So that we have to check that where is our series parallel circuit. Yes, these are the series parallel tutorial. So I'm just opening it. Here you can see all the terminology that we have used earlier, that how to measure resistance, how to measure voltage, how to measure current. So you can do first step from over here, and in this tutorial you have to connect similar way all the things that is mentioned over here, then you have to simulate it. Here what we will do, first I am doing simulation, then you can check it out. We have connected battery, that is lithium cell coin battery. Here we have connected a multimeter in series, mean we are measuring current, and here we have put it voltmeter over here, mean multimeter in parallel, mean we are measuring voltage. In complete circuit 3.9 milliampere current is flowing, 2.02 volt, that is voltage across LED. In similar way, here we are measuring voltage, here we are measuring current. Current is not flowing in the circuit. Why it is happening? Because we have connected over here, both the LEDs are in series, but current is not flowing. It's very important part that we have to understand. So first we have to check it that how much resistance it is having, because the voltage get dropped over here is 1.5 volt, but here current is not flowing in the circuits. For that we have to check resistance is very small, LED is glowing or not. Yeah, LED is not glowing, mean when we are connecting LEDs in series, mean the voltage get dropped down and very small amount of current will get flow over there. That's why here very small current is flowing and LED is glowing very small, because it's 3 volt. When we will connect over here 9 volt, then LED brightness will get increased. So I'm just removing this and putting over here this one part. Let's check it out. Okay, now we have to check it. It is working. No, it's reverse voltage is flowing over here. We have connected battery in reverse order, so we have to make it positive. Positive means this one is cathode, negative part. So this part we have to connect with this side, and this part we have to connect with this side. So now circuit is complete. Now you can see current is flowing over here 67.7 milliampere. So as we are increasing voltage, that's required voltage should be, we have to give input. If we are giving lesser voltage, LED proper brightness will not come. In similar way, there are all the LEDs in parallel. In parallel, voltage will be same. In series, voltage will get divided, mean decreased. More number of LED we will use in series, their brightness will slowly get reduced. In parallel, more current it will take, but voltage will be same in all the LEDs. That is very important part, that you will understand in the tutorial part how series and parallel circuit work. So you did it. Go back to projects. Then you can do many projects. Now I'm just doing basic circuit without any kind of project. If you have to make, go to circuit and then open just basic new circuit, create new circuit, and if you have to create any LED example, LED blink example with button or potentiometer, you can create over here. Just drag and drop, and you can take breadboard also. Just breadboard you will find. You can search over here. This is breadboard, and there are different type of breadboard. So I'm just taking breadboard over here, just connecting a component with breadboard, then deleting it, then taking LED. You have to put, how you have to put, just I did it, it get connected. You have to use resistance, you have to rotate it. You can do it from over here. Okay, I did it. Now I have to set it properly. Then I have to use battery, or I can use button also. I just taken it. Okay, took it just one step ahead. Okay, this is connected. Now I have to take a battery I have connected over here. This one is negative should go to negative, positive should go to positive. Now I have to connect two wire. One positive should go directly to the button are cross connected. When we will press button, now we have to connect it with this part. This circuit is get complete by doing this. This is negative part, you have to connect it with negative. Yes, mean current start flowing over here and over here. We can make it simple circuit by just moving it 90 clockwise direction, just putting it over here. Means it is connected internally and this is connected with it. These are connected internally, not like this, only horizontally, vertically. So now I am just going to start simulation. You can see LED is not glowing. When I will press button, then we have to see it's working or not. It's not working till now. Now we have to see this is cathode, this is negative part, we have connected it with positive part. So we have to reverse LED polarity. For that we have to rotate LED. Yes, we have to rotate it. You can set its position also. We are just checking it. Yeah, now it's working. So similar way you can make any kind of circuit, complex to complex circuit, and you can simulate over here. There are plenty of sensors, plenty of motors. You can put the motor over here also, and you can measure speed of that motor. I'm just replacing this resistor and this LED with the simple motor. So I just did it. As I will press motor, 17,000 RPM is coming. As I'm just stopping it, 0 RPM. You can simulate it real time. So it's very interesting software. And there are a lot of basic example also. The basic, these are the examples. So these are the LED example. You can use this one also, this one also. So I'm just showing you one simple example with the sensor, so that you can understand in a better way how it works. I'm just taking this for just controlling motor speed. I'm just deleting it so that you can understand in a better way. Yeah, so this one is for home. You can do all the things at home so that it will get properly. So I'm just simulating it. Mean when we will put light over here, motor speed get increase. You know, in LDR stand for light dependent resistor. In LDR, when we are increasing brightness or sunlight, mean resistance get decreased. Resistance will less, motor speed will be high because more current will flow over the circuit. You can see over here, as I'm just decreasing light value, you can see motor RPM. So this is all about simulation. So these things we have to do practice at your home, and in next session we will do a little bit advancement. Thank you so much.